Children, some more examples from 6.4. Question number 2, you will try yourself. Third one is similar to this. I have solved the third one for you all. Okay. So in the third question, it was said, find the approximate value of f of 5.001 where fx was given as a polynomial. Okay. Yesterday we had done finding the approximate value there, where you had to define the function on your own. Okay. Here your work is all the more easy because the function is already given to you. Right? So you just need to think of your x and delta x, find delta y, and then evaluate your fx plus delta of fx. Okay, fine. So that was your question. So obviously if it is a polynomial, then evaluating f5 is going to be easy for us. So I have chosen my x as 5. So whatever was extra here is the error in the value, delta x. Get it? Okay, so we will take our x as 5, easy to evaluate, and the remaining as the error delta x. So if that was your function, you will find f5 from here. f5 is coming out to be minus of 35. Okay, then we had to find the derivative of the function. So f dash of x is coming as this, 3x square minus 7 2s are 14x. Okay, again this will also be evaluated at the point x is equal to 5. So that's the value of your derivative, which is 5, coming out to be 5. Okay, now error in the value of the dependent variable, so which is to be obtained as f dash of x into change in dependent variable. So f dash x already evaluated as 5 here. Then this error was 0.001. So our error in the value would become 0.005 would be the error in the value of the function because of that error in x. So f of 5.001 will come out to be whatever y or fx was evaluated plus delta y or delta of fx. So y was evaluated as 35 and the error was evaluated as 0.005. So adding that, this was minus 35, sorry. So the resulting value, that means if you find f of 5.001 here, putting in this polynomial, then the value will come out to be minus of 34.995. Get that? Okay. So second was similar to this. You'll try that on your own. Now in the fourth question, they are saying find the approximate change in the volume of a cube of side x meters caused by increasing the side by 1%. Okay, here so this error is shown to you in percent form. So from here, children, there are few more terms that we need to know. I've put that here for you. Just note that down, that this delta x that we say, that is termed as absolute error. ये जो हम error निकालते हैं, इसको we say this is the absolute error in the value of your independent variable. Then if you consider the ratio of this error to the original value, delta x upon x, that is defined as relative error. Okay, and then if I multiply this relative error with 100, that the error obtained is said to be percentage error. So in this question number 4, they have given us the percentage error out here. Percentage error has been highlighted. So hence I told you that. Okay, so in question number 4, okay, let me read the question first. So our question was, we had to find the approximate change in the volume of a cube of side x meters. So we know what is the formula for volume of a cube if the edge or side is x. So volume is equal to x cube. Volume for a cube is x cube. We know we'll have to differentiate. So dv by dx is 3x square. Right? And what was given to us was percentage error, which is to be denoted as delta x upon x into 100. This is my percentage error, which was given to me as 1% for this particular question. Okay? And we were supposed to find the absolute error in volume. Okay, approximate error, तो वो absolute error की बात कर रहा है. That means निकालना क्या है हमें, delta v, change in or error in volume, just the absolute error. Okay, so by formula we know that delta v is dv by dx into delta x. So dv by dx, delta x from this given value, taking x and 100 to the other side of the equation, your delta x will become x upon 100. So that value you will substitute here. Okay, so we can say by equation 1, we have replaced our delta x by x upon 100. Okay, which accounts to x square into x will make it x cube. 3 upon 100 becomes 0.03. So this is the absolute error in V. Okay. Likewise is your fifth question. You have to find the approximate change in the surface area of a cube of side x if caused due to decreasing the side by 1%. So when this word decreasing has come, the only thing that you'll keep in mind in addition out here will be you'll put a minus sign. So we would say delta x upon x into 100 is equal to -1 ले लोगे. Okay, put a minus sign there. जैसे अभी यहाँ पे मैंने 1 रखा था, you'll keep it as -1 because they have mentioned decrease word out here. And then surface area of a cube is 6x cube. Differentiating, try that question on your own. Okay. Now sixth one is saying if the radius of the sphere, is measured as 7 meters with an error of 0.02 meters, and then you have to find the approximate error in calculating its volume. So if an error of this much is created in the radius, then how much will that affect the volume? That is what you have to find. So for this question, you will take it as your R is mentioned as 7 and the error in R is mentioned as 0.02. Okay, and we have to find the error in the volume. So first we need to connect volume and radius, and we know volume of a sphere is given by 4/3 pi r cube. So we will find its derivative. dv by dr would become 3 will come here, cancel out this 3, 4 pi r square. Okay, so our question was to find this change or error in volume, delta V, which we know by theory is dv by dr into dr. Okay, or delta r. So 4 pi r square, that was your dv by dr, and r's value was 7. So hence 4 pi 7 square into delta r was 0.02. Okay, multiplying that, you get it as 3.92 pi. It was volume, so obviously meter cube. So this much error would occur in volume, value of volume, if this much error has occurred in the value of radius. Okay. Okay, rest of the questions are all repetitions, just practice purpose, children. Okay, like the seventh one is radius of the sphere measures 9 with an error of this. So you know you'll take your r as 9, delta r as 0.03. Then you have to find the approximate error in calculating the surface area. So you'll find the formula for surface area of a sphere. Okay, differentiate that and then accordingly then put the values. Okay, this type of question I've already taken earlier. Both are kind of repetitions. So you try these questions and finish off with that exercise. There's not much to be done in errors and approximation.